Guys, in this video, we're tackling a statics problem involving a beam with two supports, a pin at one end and a roller at the other. This setup is really common in engineering, especially in structures like bridges and frames.
Our goal is to figure out how the beam stays balanced by finding the reaction forces at each support. We'll be using the three equations of equilibrium. First, the sum of forces in the x direction, the sum of forces in the y direction, and the sum of movements.
We'll go step by step, starting with the free body diagram and ending with a quick check to make sure everything adds up. Each of us will handle one part of the process so you can see exactly how it all fits together. Let's get started. Hello everyone, I'm going to start off by introducing our problem here. We're going to have a 120-inch long beam with our starting point being A and our roller point being B. There's going to be two forces acting down on our beam. First one, 30 inches from point A, being 800 pounds downwards, and 80 inches from point A, 1,600 pounds going downwards. So our goal is to find the magnitude of the forces going on the x-axis and the y-axis, respective to A and B. Our knowns are the length, the loads, while the unknowns are the magnitude of forces.
So in the horizontal direction, there are no applied loads. Only at the horizontal reaction AX. By the equilibrium condition, the sum of horizontal forces equals 0. We don't find BX because the roller at B cannot receive horizontal forces. So BX equals 0 by definition.
Next, we'll sum up moments about point A to find point B of Y. Moments from the two downward forces rotate clockwise, and the reaction at B rotates counterclockwise. Now solving for B of Y, we can see that once we solve this equation right here, we get 1,266.7 pounds for B of Y. This tells us that the roller at B supports most of the load because it's closer to the heavier force.
Hello, Mohammed here. Now we'll find AY by using the vertical equilibrium. The sum of the vertical forces should equal to 0. So you get AY plus BY minus 800 minus 1600 gives you 0. So AY is equal to 800 plus 1600 minus 1266.7, giving us a final force of 1133.3 pounds upward force. So the vertical reaction at point A is 1133.3 pounds upward.
Finally, let's check all of our answers to make sure they make sense. So the summation of F of Y is 1,133.3 plus 1,266.7 minus 2,400, and that equals 0. And the summation of M of B is 1,133.3 times 120 minus 800 times 90 minus 1,600 times 40, which also equals 0. And since all the equations balance, which confirms our solutions are accurate. So A of X equals 0 pounds, A of Y equals 1,133.3 pounds upwards force, and B of Y is 1,266.7 pounds of upward force. So in summary, we use the three equations of equilibrium to solve for all reaction forces on a beam. This method ensures structures remain stable and safely support applied loads.
Drop it.